Hello, good morning, good afternoon, good evening to all of you. So we are going to start our session right away. We have just we have a mentor, Mr. Sachin, who is going to take over this all the sessions, all the 6 sessions from today onwards for the coming all the 6 weeks, 6 weekends. I mean, on Fridays. It depends on whether it will continue on the Friday because we may shift over to on a Saturday morning. It depends on what is the slot available in the Saturday morning as well. So in Saturday morning, we have the DevOps as well as the cyber security, and we have uh, right now introduced AI and data science. Okay. So if in the meantime, if you have any questions like uh, what are you looking at in these sessions and all those stuff, though it will be explained very well. Uh, Sachin will be explaining about
Hello
the
everyone.
roadmap. Yes. Good morning, Sachin.
Good morning.
And before you start, let me ask whoever is present over here
Am I
whether
audible?
they have any questions, right, about their purpose, their intentions, or their particular you know what they are looking forward in these sessions, as well as if they have any job related questions, if they are having any regarding questions regarding the job. So you may please forward those questions, or you can also during the session you can unmute yourself. Otherwise, you please keep yourself muted. You can unmute yourself, and then whenever you want to ask a question, please uh, unmute yourself and you can ask the questions, or you may put that question in the chat box. Any questions from your side? Okay, if there are no questions, Sachin, I would request you if you can start off. Thank you very much.
Thank you, sir. Thank you. Okay, so first of all, a very good morning to all of you. And I know that it's a quite different time zones we are dealing right now, right? So first of all, I would like to thank everyone, those who are joining the session, and I would also like to see. The thing is, I would like to make this session interactive so that we can gain the best of the things that we are going to discuss from this session. Okay, so I hope that everyone will be interactive, attentive in the session, and make sure that whatever doubts you have, whatever things you are stuck with, right, or trying to understand on this domain or the future of it, right? I would like to get more of the questions from everyone. Is it fine, everyone? If it's clear, you can put a yes in the chat. Otherwise, we are going to start.
Hey, good morning, Sachin. How are
Good
you?
morning, sir. I'm good, sir. Thanks.
Yeah. It's nice. It's early morning for you guys, but it is little. No, the timing is not that good for us because it is Friday evening for us, right?
Mhm.
Everyone has like a little bit, breathing space after a long week. So, and hopefully, I think by next 1 week or two, this Friday, Saturday, and the next Saturday, our cybersecurity session will be done. Then we can shift to we just need to discuss like the find the other timing. Then we'll have another availability in the Saturday. So then it will be you and Mr. Devashi's discussions, which time is good for for all of us.
No
And
worries.
thank you for joining in this early morning. I can see most of our Indian folks they are not present at today's call
Mm, mm, mm.
because it is I can understand this Z generations people. It is it's very tough to wake up in early morning. Uh, yeah, and hopefully. They can stay in that way because once you move forward in your life, life will
Exactly.
throw
So,
many
so,
challenges,
Mr. Menon, are you saying we are old people?
including me.
Okay, okay, no
So
problem.
now be cautious. You can whenever you want to discuss with Mr. Devashish, don't ask anything about age. So he sometimes he got offended. So joke, joke apart. So thank you again. So I think we can, guys, before we move forward, if you have any questions, discussion, and please make this conversation interactive, and I can give you in a written that this is a one of a kind opportunity you will find where you can discuss with people like Mr. Devashish, Mr. Sachin, who are right now working as a in who are right now working in industry in this cutting edge technology as a top senior most positions. So you'll not only get the ideas about the skills, the technology, you can also get the huge overview of how the job market works, how to get those jobs. Because I can assume most of our people who have joined here either they are in the job market, or they maybe and many of them already working as a data scientist or AI expert, but they wants to explore furthermore and learn furthermore to so they can leverage on their present job positions, right? So make the time useful and um, okay, and we can move forward, right?
Sure, sir. Okay. So thank you, sir. Now let's just begin with the session, guys. Right. So first of all, I would like to understand that how many of you think that the data science or the data analysis, right, that we are going to do, or basically we are discussing today about the a, a topic you can say kind of that is called as artificial neural network, right? So can anyone tell me what are the applications or what are the real-time scenarios you have faced so far in which you think that there might be some point of working of neural network is there? If anyone wants to give any output, anyone? Frank, Toyin, Chandra, I can see a lot of people here. Okay, can anyone tell me that what is basically the data science? Why anyone heard about data science or what could be the future of it? Anyone knows that? So few more people
I
are
have no
joining.
idea.
No idea. Okay. Okay. So see, understand. First of all, we need
But
to understand. Yeah. Okay. First of all, we need to understand that what is data science, right? See, uh, if I break down the data science or the term data science, so I can simply say that it's not about that we are putting any, you can say, some sort of rocket science behind this. Nothing, right? Simple thing are that we are integrating the mathematics, some statistics point, and your programming language. That's it, nothing else, right? So everything is either built on purely on you can say logics, and behind logic, you have mathematics, right? If I say that I need to simply add two, you can say two variables, okay, I need a logic behind that. What is the logic? The logic is of that plus sign, right, which we call as an addition. Simple. In the same way, when we go into the, we are not doing any things that are uh, quite, you can say, complex or just restricted towards a specific domain of people. No, it's not like that. If you understand the terms, if you understand the concept, right, if you have a clear understanding of mathematical concept behind that, anyone can be a part of this data science domain right now. Okay. Uh, okay. So when I'm saying that statistics and mathematics, it's not about the classical mathematics or classical statistics, not like that, right? It's not like that we are going to apply some, you can say, very complex things there. Might be in some algorithm you require, right? When we go into the deep learning part and we go into the, you can say, the LLM things, right? Then it might be possible that you have some kind of complex things, but not in the entire data science part. Another thing is that coming to the implementation of it, that how you're going to implement it. Okay, because someone can understand the concept, someone can gain the concept, right? But how to implement it? So to understand this, we need to look into the types of languages that are available right now. So basically, there are two types of languages, and one is not preferred most of the people. The thing is, because that is purely based on statistics. Okay, and here I'm talking about the R language. So R language is basically deals with your more into your research part, where you have kind of good coding practices. You need to understand a lot of libraries, the types of libraries, the working of it, and the methods that are involved in that library. Okay. Then coming the latest, or you can say the current language which is prevailing right now in the every industry. I'm talking about Python here, right? So can anyone tell me any advantage of using Python, or anyone working on Python right now? Yes, no?
I never use Python, so I don't know.
Okay, thanks. Anyone else?
As compared to other language, the Python syntax are very easy.
Okay, Python syntax are very easy. Good, good. So I got one input that Python syntax is very easy. Okay. Uh, Anyone can tell me about what makes Python more reliable in terms of data science or machine learning?
But library and packages, like you can install any libraries in a simple way.
Right, right. So the thing which makes the Python uh, famous among everyone right now is the packages or the libraries, right? Which is giving, or which is coming in the Python itself, right? Currently, the repository of Python, which we call as a pip, that is Python image packaging, right? Pip coming with around more than 10,000 plus libraries. So you can use those libraries according to your need. There is no need to install every library. No, Python gives you a freedom which makes uh, to pick your library according to the need. right? Another point about the Python is that it is interpreted language, right? So there are two types of, or two categories of language we generally go with, that is a compiled or the interpreted, right? Uh, we will talk about that later, what is interpreted compiled. So when we say interpreted means the execution time of Python is quite uh, low. Okay, so you get your output in very low time, which makes the Python again user friendly or hardware friendly as well. Right? Now, without wasting more time on the discussion, I'm coming to the point now. So today we are going to discuss the topic that called as ANN, right? And ANN stands for Artificial Neural Network. Okay, I hope that few of you have heard about it and few are just new for it. So may I know how many having update about the artificial neural network or something like that? Yes, no? Anyone?
I think Jose, do you have any question or you just raise your hand? Jayman? Jose, do you have any question? Or you raise your hand because you know the neural networks things. That's the reason you raise your hand. Please, it is an interactive class. Whatever you have to discuss,
Hello.
discuss.
Uh,
Yeah, do it.
I raised my hand before because I was
Yeah.
talking about Python and
Mm-hmm. Yeah,
and
go ahead, please.
uh, and the Python is used for sometimes I just use it for a basic like calculating some items, but that's the place I stop. But it's generally used by software engineer.
Okay,
Hello?
okay,
Mhm.
fine, good, thanks. Okay, so Daniel is asking, repeat the question. Sorry, fine. Daniel, I'm asking that what is neural network? Okay, what is neural network? If anyone know about neural network, can raise your hand or you can unmute yourself.
Yeah, Daniel, please go ahead if you have to say something about neural network.
Sorry, can
I
you
think,
hear me now?
yeah, Daniel, go ahead.
Okay, I've not really done done anything on it, but I've heard about it, but I've not
Mhm,
really known more about it. But I've done something on uh the other one, the NLT, the
mhm, mhm.
National Language Processing stuff, where I had to use one Python module that I installed and Tinker or something like that to process natural text just to do what I wanted to do. That was in the past anyway. But I've not
Mhm.
really done or known more about neural network.
Okay, thanks. No issues, no issues. We are going to discuss about that. Thank you. Okay, Benga is raising hand. Benga, can you go ahead?
Okay, good morning.
Good morning.
I've done something on neural network, precisely convolutional neural networks.
That's awesome.
Neural network is just mimicking how the human brain works,
Exactly,
how it processes
exactly.
information in form
Mhm.
of interconnected neurons.
Correct, correct.
Yeah,
Exactly,
so
exactly. Thank you. Thanks. Okay, so I got one input that so Banga is describing neural network as a, you can say a code or a program that works just like a human brain. Okay, and we know that how human brain work. Okay, basically we know about how human brain work. And I'm not going into the more into the biological things, but how the human brain work we know about it. Okay, so let me do quickly just one thing. Just a second. Let me just sign into my whiteboard so that I can have more of the. Just give me a moment. I'm opening the whiteboard. I hope the screen is visible to everyone. Yes, no?
Yes, it is.
Okay, thanks. So we are going to start, or we are going to discuss about the artificial neural network. Okay. So first of all, let's begin with the neural network. Why it's working? It's not working. Just a second. It's not working. Strange. Okay. Let me just quickly refresh it.
Sachin, I don't think your screen is visible.
Yeah, I just stopped it. I am
Oh,
just
okay.
refreshing my whiteboard. Okay. Just a second. I'm just refreshing it, and then we are going to start. Fine. So till then, so what is basically a neural network? Okay. If I talk about the neural network, you can understand it like how the brain works. Okay. So we are going to start with the functionality of the brain. We know that whenever you receive some information, it is processed in your brain. Okay. And when I say that it is processed in your brain, it doesn't mean that entire brain is working on that. No, a small portion of it, or you can say a, a unit of brain, right, is going to work on it. Correct. Now, so in brain, when we say that we are having some sort of information received by our brain, right? So that is going to be dealt with neurons, right? Or you can say that the information is received by some receivers, right? So there are two types of entities. I hope my screen is visible now.
Yes, Sachin.
Okay, neural, right? So see, so what happened? When we dealing with the information, or when our brain receives some information, so there are two type of entities that is going to work on it. First is a receiver, and another one is a transmitter, right? Receiver means who is going to get the information, right? And once entire information is going to process through the neurons. Okay. Further, the instructions that are generated by the neuron is going to transmit it by the transmitter, and then your muscles or other reflexes is going to work, right? So that is a basic understanding of how your brain works. Okay. Now, if I try to relate it with the neural networks that we have designed, and we call them as artificial neural network. Artificial neural network, right? So as the name is suggesting that we are designing some neural network artificially. Okay. Now there are some component of it that we are going to use. Okay. We are going to define. So what are the components? We will coming to the next point on that. Now, first of all, understand that how we are going to define this a neuron artificially. So what we basically do here, understand. So there is a term when you start working on neural network, there is a term that is called perceptron. Okay. What this perceptron is? Perceptron is the smallest unit of any neural network. Okay. Now, what is inside this perceptron? So perceptron is not like that it's a single entity. No. Inside the perceptron, you have basically two types of functioning, right? Now, what is that? So let's suppose I'm saying, so let's suppose this is my perceptron, okay? And inside this, I have two functionalities. So I have divided this perceptron into two parts. Now, one is called the summer. Now, it's not about the weather I'm talking about, it's a summer. So we will talk about that, what is summer. And another one, another part of the perceptron is called activation function, right? Activation function. Now, what is the summer? So summer generates from the term sum, that is a cumulative part, okay, where you are getting some cumulative result of it. So here we are doing the summation of it. Now see, understand here what we are doing. Let's assume that some information is received through to this perceptron, right? So let's suppose these are the informations that is currently received by the perceptron, like this, okay? And let's say I just give it some main name, so x1, x2, x3, and so on, or till xn. Now, what this arrow here is, I will talk about it. So these are the inputs that we are getting, and obviously there are some sort of you can say the priorities that you need to mention. Okay, let's suppose, for example, at a particular instance of time, you are receiving multiple information from your surrounding. Okay, then which one having the most highest priority? So for that particular thing, or to define that, you can say define that need, okay, to process the information on the highest priority, we define it using the weights. Okay, so weight, so let's suppose W1, W2, W3 goes to so on to Wn. Now these weights, so what is x1 x1 to xn here, and what is W1 to Wn here? Okay, So x1 to xn is my input, and w1 to wn is my weights. So what are weights? Weights are nothing. Weights are simply some mathematical values. Okay, that is your numerical value. Simply done. Now, how these weights are designed and how we are going to initialize the weight. So most of the time, there are predefined weights coming for your neural network. Either you are using some uh, frameworks or you're designing any kind of neural network. So weights are already defined there. But in case if you want to calculate your own weights, so there are entire calculation is there uh, that we will see in your you can say deeply when we will discuss about it. Okay, so as of now, just understand that weights are some numerical values that is used to define the priority for the information, right? Now, this summer, what it will do, this summer will generate a equation, and how that equation is going to create, how that equation is going to generate. So we are generating this equation through the product of every input with its weight. So we are talking about the dot product here. Okay. So simply I'm saying that this summation, let's suppose okay. So this summation is simply your x1 dot w1 plus x2 dot w2, right? And so on it goes till xn to w1. Okay. So this is the first basic equation that you got. Now, if you look at this equation, may I know what is the nature of this equation? If anyone understands, what kind of equation it is? You can unmute yourself, guys. Anyone wants to give any input? Okay, see. So
Daniel
currently,
has said it is linear.
good, very good, Daniel. Sorry, I'm not looking at the chat right now. So it's
Yeah,
better that you guys are just use your microphones. Okay, so this equation is currently linear. Now the question is that if the equation or if the result is coming as linear, then why we are not going to the more classical algorithm that we have already, right? Like linear regression is there. So why we are not using that? Understand? Whenever you are designing a neural network, okay, it's not possible that your neuron get in a or your neuron will be in a working position at every time. Okay, it's a continuous working position. No, instead of that, what we want that whenever you want to activate it, your neuron works. Okay, that is the reason now we are dealing with another entity in the same perceptron that we called as activation function here. So generally, this is a symbol we use to represent the activation function. Now, what is activation function? Understand. Okay, let's take an example to understand the activation function. Okay, so fine. So let's say that okay, let's understand like this. So let's suppose, for example, you are going or you are driving a car. Okay, and you are driving it normally. There is no hurry and everything there. Now, all of a sudden, if an object comes in front of your car, right, what you are going to do? Most of the time, there are only two or three options are there. Okay, either you drive it away, Another, if your speed is not that much high, right, you are going to put brakes, apply brakes. Otherwise, if you are not attentive or your brain is not that much functional, most of the time you are going to hit that object, correct? But if I'm saying that as soon as you identified that object, identified the you can say identified the consequences of it, right? Your brain automatically generates some reflexes that are not voluntary. I hope everyone agreeing on that. Yes or no? Correct? So your brain generates some involuntary reflexes, correct? And those reflexes are basically generated through the neurons. Okay. So as soon as you identify the object, or as soon as your brain identifies that object, it generates a reflex, and according to that, neuron get activate, and your body or your muscle get work according to that. Clear? Anyone have any question or doubt? You can go ahead.
Yes, can you repeat again, please?
Which part?
I mean, the last part that you were just explaining.
Okay, fine. So what I'm saying is, okay, let's assume like this. Okay, let's take another example, a simple one. Let's say you are just walking in your home, okay, barefoot, generally, and you step on a sharp object. Let's suppose a pen, right? So what will happen? You are not going to make any action. You are not going to do any action. As soon as you step on that object, your brain automatically sends some instruction to your muscles, right? Correct? And you just step out of that object, right? Getting my point? I hope everyone getting the example. Frank, now it's clear, I hope.
Yeah, I get it. I get it. Thank you.
Okay, right. So how that reflex generate, how that you can say how that muscle got information, muscle got instruction. So that is all through this activation function, right? So that is why when you are working with any neural network, we have to define that what kind of activation function we are going to deal with. Okay. Now, so here we talked about the linear, right? And we understood if there is the you can say the output is of linear, so what is the we can say what is the use of neural network? So that is the reason we introduce the activation function, which makes this linear transformation into a non-linear transformation. Non-linear transformation. That is why we have the types of activation function based on it, which is linear activation function, and non-linear activation function. Okay, non-linear activation function. Now, we are not looking for the linear activation function because we know if you go for the linear activation function, it will work like a regression. So what we do, we generally go for non-linear activation functions. Okay. So there are multiple type of activation functions are there, like the basic one, or the simplest one is called the sigmoid function, right? If any one of you used to work with classical machine learning algorithm or developing the models using the machine learning algorithm, okay, I hope you know about sigmoid function. Now, what is sigmoid? Okay, let's Let's just understand a little bit about that. Okay. So what is sigmoid? Sigmoid function says that I will only work in case you have binary variables, or you can say binary output. Okay, binary output means if you have the output in the form of 1 or 0, like this, right? Now, so sigmoid say that I will use a threshold value, and on the basis of this threshold value, I am going to convert all of your probabilities, all of your instructions, all of your information or the output into only two categories, that is either 1 or 0, right? Clear, everyone? So that threshold value, sometime it is determined default, or sometime you can also initialize it, right? If we talk about, you can say a convolutional neural network, which is basically used to work on the object detection part. In there, you can define this threshold value. So there is kind of a, you can say methods are there, okay, which we generally use to define this threshold value. Okay. Now, another aspect of sigmoid function is that it is simplest one, simplest, and also it converges very quickly, means your algorithm converges very quickly and generates a very good result. So that is the reason most of the classification algorithm or most of the classification neural network in which you are going to deal, we use this sigmoid function. Okay. Now, if you want to understand the logic behind it, that why we call it as sigmoid and all, so there is an entire derivation of it. So first of all, there is probability. We calculate the probability, then we calculate the odd ratio of that. Then we are going to do some, you can say, some calculation on that, you can say equations that we get, applied the logarithmic functions, then take the exponent of it, and finally you got a function. So sigmoid function is basically we denote using the z, 1 upon 1 plus e to the power minus x, like this. Okay, so this is the basic formula or basic denotion how you denote the sigmoid function. Okay, so sigmoid say, if I talk about the graphical representation of it, so sigmoid say, let's suppose if this is my okay, this is my output. Okay, and there will be some threshold. So I'm assuming threshold right now as 0.5. Okay, 0.5. So what this sigmoid say? Understand what this sigmoid say? Sigmoid say that if you get output in the range of 0.5 to 1. Okay, because we are dealing with the binary output, so that means your the only range of the output is 0 to 1. So it means that if you get output in the range of 0.5 to 1, it will convert every value of this range to 1. That means this is your output, and the values below 0.5 to 0 that are going to be treated as 0, or that are going to converted as 0. So this is your 0 part. Okay, that is the reason. If you look at any time to any you can say the output of the sigmoid function, you will see mostly the graph like this, a kind of S shape like this. Okay, so it is nothing, it is just a smooth curve that you got from this applied algorithm or the applied you can say sigmoid function. Okay, so this is the result of it, where one part is giving you the first or the one, and the another part is giving you the zero, right? I hope this is clear to everyone. Anyone have any question or doubt? Guys, if any time you have any question or doubt, you can raise your hand. Okay, Daniel raised the hand. Daniel, you can go ahead.
Okay, can you hear me?
Yeah, I can.
Yeah. The little question I want to ask is about the activation um energy is it graph or activation thing. You
Can
made
you please little bit louder?
hello, can you hear me now?
Yes, that's perfect. Yeah, go ahead.
Okay. The question I have is based on the activation um stuff that you
Activation
just
function.
explained.
Activation
Yes,
function.
that you just
Hmm.
explained. You talked about you moved from the linear to the
Non-linear.
non-linear.
Correct.
Okay,
Correct.
so the question that I want to ask is, does it mean that once the the presence of this um activation uh function makes it to be non-linear, or is it that every of the um um how do I put it? Um okay, just simply, does it mean that it must always be non-linear, just like you try to explain to us? Or does it mean that some have to be linear and some have to be non-linear?
Okay.
That's my question.
See. The thing is, as I said, that as I said, that if your output is a linear, then there is no need to design the neural network, right? Because we are already having algorithm to work with linear, you can say, a linear equations. Okay, there are a lot of algorithms available. Also, the to you can say you see that mm, processing the information. Okay, because neural network takes a lot of information. It takes a lot of input from the surrounding. Okay, it takes a lot of input from the data. So if you design a linear equation, it might be possible that your algorithm or the basic things or the basic algorithm is not going to work according to the need. Okay, or it will not generate the expected output. So that is the reason what we say, that we use some sort of different method, say some sort of different mechanism. That is basically we introduced using those activation functions, which made that linear equation into a non-linear equation, right? I hope now you're clear.
It's better now.
Okay, right, fine. So this is what sigmoid function. Apart from this, it's not like that, not like the we only have this sigmoid function. No, we have multiple functions as well. Instead of sigmoid, we have 10h, we have ReLU, we have leaky ReLU. Okay, there are a lot of activation functions out there. I'm not going to talk about those activations right now, but as of now, just understand what are the activation functions. Activation functions are functions which activate your neural network. Simple understanding. Okay. Now, let's talk about the component of neural network. Till now, we have discussed about the working, how the neural network is going to process the information and all of the things. Now we are going to discuss about some component. Okay. So when we say component, so here we are dealing with layers. Components are nothing. Components are simply the layers. Layers in neural network. Okay. Okay. See. So in neural network, we are primarily dealing with three types of layer. First is called the input layer. Second is called the hidden layer. And third is the output layer, like this. Okay. So let's suppose, let's say this is my input layer. This is input layer. Then we have the hidden layer. And finally, we have output layer. Okay. So I'm assuming that right now I'm working with binary output. So there will be only two neurons like this. So all of these circles are nothing. These are neurons, right? And every neuron is connected with each other like this. And finally, sorry. And finally, we have our output like this in the form of either 1 or 0. Okay. Now, what happened actually here? First of all, in the input layer, sorry, first of all, in the input layer, you will get input from the surrounding or from the data, right? So if you remember, when we are talking about the perceptron, I represented the input as if you talk about this, so I represented the information by x1, x2, and x3 like this, right? And a weight associate. So weight and this input is going to process in the first layer, which is the basic one. This is called the input layer. Once you have initialized the input layer, so what things you need to determine here, you are going to determine the how many neurons that you are going to define for it. Okay. And how we are going to do this using the Python, or how we are going to do this implement using the Python, we will shortly come into that part as well. That is where we are going to implement it. Okay.
Sorry, Sachin.
Yes, sir.
Benga has a question.
Mhm. Yeah, go ahead.
I was just asking, You mentioned several activation functions: ReLU, leaky ReLU, sigmoid, softmax,
Uh-huh.
and a host of others. And I
Correct,
was
correct.
just asking to know
Uh-huh.
in which context. Sigmoid is quite understood that, okay, it
Uh-huh.
is used when you need binary values,
Correct,
but
correct.
in what context do you use each of the activation functions?
Okay. See, so understand like this that you have a very basic data, or you are working on very basic, or you can say you are designing a very basic simple application for our data, okay, where you are going to do some little bit of classification. You can use a sigmoid function in that one, okay. But when you are dealing with your high, or you can say more complex data, okay, you need a different activation function, and you also want that your algorithm or your model get converged into less time, okay, because there is no need. See, understand, if you're designing a neural network and it is taking a long time to get converged, so there is no need, or there is no you can say importance of it, right? Means, let's suppose for example you are giving some instruction right now and you got your result after 3 or 4 minutes. There is no need of it, correct? Now, when we are dealing such type of scenarios, in that case, you are going to use different type of activation functions, like we have ReLU, leaky ReLU, okay? Because the range on which they are working, okay, like sigmoid function, what sigmoid say? What is the range of sigmoid, anyone?
Zero
I
and
think
one.
0 to 1.
0 to 1, okay. And what will be the output of it?
One.
It's going to give a non-linear output, right?
No, no. Obviously, it is not. It will be a non-linear output. I'm not asking about. I'm asking about what is the output range of sigmoid.
It should still
Run.
be binary.
It will be binary, right? So binary. Your output is binary and your range is also binary. No, it's not like that. First of all, understand the range of sigmoid is minus infinity to plus infinity. Means it works from the minus infinity values to negative plus infinity value, and all of that values got converted into either 0 or 1. That is what we call as the output range of any activation function, okay. So just like sigmoid have minus infinity to plus infinity, in the same way, if I talk about the 10h functions, 10h function also having this kind of range like that, okay. So uh, sigmoid works on 0 to 1, 10h work for 1 to minus 1 to 1, okay. Similarly, ReLU is a different nature. Leaky ReLU. Leaky ReLU is used to, you can say, cover up the problem of ReLU. You can say, okay. That is why we call it as a leaky ReLU, because it is covering up the, you can say, covering up the not errors, but the some consequences of using ReLU on a specific type of data, right? So according to the need and according to the expected output, that what kind of output you want to generate, you can use different type of activation functions. I hope, Benga, you are clear now. Okay, fine. Let's go ahead. Right. So we are dealing with the architecture of it. Okay, so it's simply the architecture of a neural network I have designed here. So first is your input layer, which takes the input as well as the weights. Okay, so W1, then W2, and WN. Now, all of this information is going to pass to this hidden layer. Okay, or sometimes we call it as dense layer as well. So when you implement it, when you going to write the code for this, there is no hidden layer. Okay, the word or the name that we use is called dense layer, right? So dense layer is the main layer in which your entire processing happens. Your optimizers are going to work here, your activation functions are going to work here, and on the final, or you can say finally, we have your output layer. Means the result from this dense layer is going to finalize at the output layer, which will generate your output, that is either 1 or 0. Okay, so this is a basic understanding of how a basic neural network work. Clear? Now the same neural network we can implement in any other you can say framework, or you can say you can define a more complex neural network on the concept of same thing. But what will happen in that case, your dense layer will get increased. So there is no restrictions on dense layer or the number of dense layer. You can initialize n number of dense layer, but yes, definitely there are some consequences of it. It might make your model, it might make your neural network having or take lot of time to get converged, means lot of time to generate the output. Correct? So that is why we need to understand that what is you can say why we are using how many numbers of dense layer we are going to define it here. Getting my point, everyone? Anyone have any questions, doubts? Frank, Jose?
Yes, I think I do.
Yeah, go ahead.
You said something about the number of layers,
Yes.
and I
So,
was just asking, what
mhm.
actually determines the number of layers you are expected to use? Do you just guess, or you can maybe check results before? Maybe you test with 3 layers first, then you are able to say, oh, this result is not okay. Let me test with more layers. What actually determines the number of layers when you are building your model to obtain a perfect, a better result or better optimization
Hmm, hmm, hmm.
parameter? That's my question.
Okay, okay, fine. Fine. See, so there is no specific rule that how many neural network, or sorry, how many layers you are going to define. Okay, as I said, that more the number of layers, more the number of your hidden layers or the dense layer, it will take more time to your model to get converged. Okay, so there is a simple, you can say, standard, not a criteria, not a rule, but yeah, a kind of a convention that we use, that start with having at least 2 dense layers. Okay, if you have a very small data or very normal data, start with at least 2 dense layers. Because when you give the parameter or when you give the input to the dense layer, obviously in the first layer it's not possible that every data gets sorted or every data got processed perfectly. No, so that is the reason at least give 2, and you can move by introducing more dense layer. Okay, so as of now there is no criteria here to define how many dense layers should be there. Okay, and how many neurons as well. Does the number of layer also translate to better or more accurate result? Okay, yes, definitely number of layers will give you a more accurate result, right? But There are some cons as well. Might be it will take a lot of time, but yes, definitely you will get better result. If you have a good processing, you can say structure, good processing hardware, it will work. But yes, it will take time. Anyone else? Any other question? Doubt? Guys, anyone wants any further you can say clearance on any topic or any things that we have discussed? What other factors apart from layer or neuron can be explored to obtain better result in ANN? Okay, see, if your data is clean, okay, because see, whenever you start with your you can say with your analysis or when designing the neural network, okay, it's better to provide a clear data, clean data. Understand? Well, when I'm saying clean data, it means uh, okay, let's take an example, a real-time scenario. Now we know that our traffic signals are mostly automated. Okay, previously they work on a time frame. Every traffic signal have a specific time period mentioned in their hardware. According to that, they change the signals, right? But now we have smart traffic signals. So what happened there? Those smart signals work on the density of the vehicles, right? Now, cycle, that is bicycle, is a vehicle. Bus and truck is also vehicle, correct? Now just assume like that on a particular traffic signal, or you can say there is a four-way, and on a one lane you have, let's suppose I'm saying there are 100 bicycles, and on another way there are 100 trucks or 100 mixed vehicles are there, right? So which path the traffic signal should first make green? The bicycle one or the car or bus one? Anyone? What could be the best solution for this? First, allow all the bicycle riders or the vehicles one? Any answer?
I think bicycle one because we
Bi-
have less.
okay, bicycle one. And what is the reason that? Okay, can you repeat the scenario? Didn't get. Okay, Benga, I am saying. Let's assume. Okay, let me just write it here. Okay. See, so what my scenario is? Scenario I'm saying is that let's say this is the traffic signal. Okay, and there are four ways. One, two, three, four. On this, we have bicycle, all the bicycle rider here, and we have here different types of vehicles, right? So we have buses here, we have cars, trucks, motorbikes. Okay, so which you can say which one signal, the first needs to be activated.
I
The
think I will
bicycle.
go with the my other presenter, bicycle, I think.
Okay, bicycle. And what's the reason behind it? Why you're going with the bicycle?
See, for
Well, it
bicycle, like
depends.
One
less
by one.
density, so it will take
Le- uh-huh.
per second.
Okay, less density. Okay, fine. And why not another one?
Because we have huge density, so it will take more time. Like it
Okay,
will take 15 to 20 minutes to clear all the traffic.
huh. Okay, okay. Now just assume like this. Okay, now I'm introducing one more twist here. Number of bicycles are 100. Okay, and I'm saying that there are only 10 vehicles on this another path. Now, which one need to activate?
10 vehicles.
I think the vehicles.
Then
Vehicles side needs to activate.
correct. Vehicle side needs to be activated. Okay. Now, from this discussion, from this example, one thing we are clear that one thing we are clear that if you are having less density, okay. So when I'm saying density, being about the data or the input. If you have higher density data, then go for you can say a higher number of neural networks or higher number of dense layer. If you have less number of density of the data or less complex data, go for lower number of you can say dense layer. Correct. So you can also understand through this example that if you have a complex data, you can design your neural network, you can design your layers according to that. Otherwise, you can choose a simple one. Okay, or you can use a you can say you can use a framework as well. There are different frameworks available, right? For example, uh, let's suppose if I need to do some classification, I can create a neural network by itself. But on the same way, if I need to work on some object detection part, right? I can use a framework like YOLO is there, VGG is there, correct? SSD networks are there. So according to that, you can use your preference. You can give your preference to the model that you are going to use. I hope it's clear now, Benga.
Yes, it is.
Sorry. Okay, fine. So, right. Okay. So anything else in neural networks? So we have discussed before moving to the implementation part. Just give me a moment. Uh, Fine. So there is a quick presentation that I have created. Okay. I hope you guys have gone through that as well because it is already available on our website. So let me just share it. And if anyone wants to have any discussion on any of the slide or any of the part of it, we can do that. Otherwise, we are moving towards the implementation part. Yeah, Benga. Okay, not yet.
Yeah, there's some things I want to also know about. I hear of bias, forward
Oh,
propagation,
huh,
backward
huh, huh,
propagation.
huh.
Can you help us shed more light on it?
Sure, sure. Okay, see, very good, very good. Understand. Okay, so I'm coming to this shortly. I'm coming to the PPT shortly, guys. Okay, there is one very good question Benga raised. that okay, see. So Banga raised that there are some terms like forward propagation, backward propagation, backward propagation, and one more thing you said, you know what that forward, backward, and Benga, what is the third one?
Bias.
Bias, right? Bias.
Loss function too, please. You can add loss function too.
See, so we will start from the forward propagation first, right? Understand. If you look at the architecture which I have designed, okay, this one. So what is happening here, if you look, information is going from a input layer, then it is processed in the dense layer and then going to the output layer, right? Means there is no, you can say, a random nature of processing the information. Okay, there is a systematic, there is a sequential nature. That is why this basic architecture that I have represented here, this is your sequential network. Okay, we call it as a sequential neural network because everything is happening in a sequence. It's not like that your input is directly going to the dense layer, no, or input is directly going to the output layer, no. It must first go to the input layer, then it should, you can say, processed in the dense layer and then pass to the output layer. This is what we called as forward propagation, or we call it as feed forward network as well. Okay. Another word for this forward propagation is feed forward network. Right. Now we understood that what is feed forward or what is forward propagation means when your input is going from input to your output layer. Now coming to the backward propagation, and when you use backward propagation, first of all you need to understand what is the need. If everything is going fine with the forward propagation, that what is the need of backward propagation? Correct. Understand what is the need of backward propagation. Sometime what happens that you will not get desired output. Okay, desired output means your output is having errors. Okay, when you calculate the accuracy of your model, you will get that your model is having very low accuracy. So what you need to do, obviously you can't change the input, right? Once you get your input, you can't change it. Once the object is there, you can't change it. Correct. Now, only thing that you can change is this weights. Making sense or not? Yes, no? Right? So, to calculate these weights, what we do, we go in the backward nature. From that point of view, we call it as backward propagation. So, in backward propagation, we do nothing. We simply apply mathematical calculation. Mathematical calculation to find optimal values of weights to initialize for new neurons. Okay. I hope Daniel, forward and backward are clear. And anyone else? Any other question or doubt? I can see a lot of people, but I'm not getting any kind of question or doubt from your guys.
So I'm still expecting unbiased.
Coming to that, coming to that.
Okay, thank you.
Mogapi, Arnab, Peter, Ede, guys, are you getting anything or not? Or everything just dodging on your from?
Yes, we're playing.
Okay, good, fine. Okay, so let's move. Right. Okay. So one more term is there that is called as bias, right? Now, what is the purpose of working with bias? What is why we define bias? So as I said, you can say we define, you can say we define weights, right? Then when we have already weights, then what is the use of bias and what this value bias is, right? So let's take an example to understand bias. Mm, any real-time scenario I'm thinking of. Okay, but no issues. Let's say, okay, understand where we have this inputs and fine. Okay, so with every neuron, right, I'm going to define one learnable parameter. Learnable parameter means the parameter that you can use, that you can define. Okay, weights already calculated, right? Available. Now there is the parameter that you can define is called bias. This one. And bias, what is the purpose of bias? So bias you can understand like that it's a value which makes your neuron like trigger. Okay, correct. Now trigger on when? The question is that when is going to trigger? So it will going to trigger if any, you can say if the weights are very small or it is negligible. Negligible means if it is zero as well. Obviously in that case also you need to activate that neuron. Okay, so how you are going to activate that neuron? In that scenario this bias comes. Getting my point? I hope clear now.
Not very clear. I don't know if the you
See.
can still.
Okay, understand like this. Okay, let's understand like this that so instead of this W1, W2, W3 and so on, I'm assigning some weight to it. Okay, let's say the weight assigned with x1 is, let's suppose, 0.7. Then the weight assigned with x2, 0.4. Weight assigned with x3 is 0.1, right? Now if I look at the weights of it, obviously the 0.7 and 0.4 if I do the dot product of this of these two entity, I will get a high priority for x1 and x2. Yes or no? Benga, making sense?
Yes, it is.
Right. But what about this x3, where we have this 0.1? Is it that x3 is not going to process? No, it's not like that. Correct? Still, I need to activate the neuron. Although I am having very negligible value of the weight, but still I need to activate this neuron in the input. Correct? So in this case, what I will do, I will assign a bias value. Bias, we know what is bias. Bias means we are giving higher priority deliberately to someone. That is what bias is, a literal meaning of bias. Correct? Right? So that in that case, when you have these type of scenario where where your weights are very low, that case you define a bias. And it's not like that in only that case you define a bias. In every neural network, there is some bias associated, right? But yes, for a normal, you can say normal scenarios or a normal data, if you don't define it, it will work fine, because that will be handled by the optimizers that you are going to use, right? We have some optimizers as well. Optimizers is nothing. Optimizer basically going to calculate or basically going to optimize the output based on some mathematical calculation that we want, that what optimizers are, right? So we have Adam optimizer, we have SGD, we have gradient descent, okay, like that. So there are different type of uh, optimizers available. I hope it's clear. Now loss function, okay. Loss function, understand. Loss function, you can, if I define in a simplest way in terms of your machine learning, loss function, you can understand that the processing power or the processing or the calculations that you are going to do to make the optimal result, okay, that you can say that processing things or that calculations or nothing that are called as a loss function. So so every algorithm have a different loss function, okay, like in linear regression, like in logistic regression, that have different types of loss functions, okay. In regression itself, there are two types of you can say two type of regularizations we use, okay, to overcome of this situation, because that will cause us a lasso and ridge regressions, okay. So that is basically what loss function. So in the neural network as well, we have some loss functions. Anyone else? Any other question or doubt? Okay, no worries. So I hope every one of you get this. So let me just share the PPT quickly, so that if any one of you not able to uh, get or got time to view that, you can go through this quickly. And if you have any question or doubt, you can go ahead with that as well. So so we have discussed about the neural network, right? Computing system inspired by the biological neural network in human brain. They form the backbone of modern AI system, enabling machine to learn patterns from data, and ANN power everything from voice assistance to medical diagnostic and autonomous vehicles. Okay, so this is the basic of artificial neural network coming into the scenario, present scenario. Okay, another one. This is a history. So it starts from 43. There are two person. McCulloch and Pitts create their first computational neural network, laying the theoretical foundation. Okay. 58, Frank again comes with the perceptron algorithm, the perceptron that we discussed in the first one. Okay, and it is mentioned here, the first trainable neural network. Then in 86, Hilton, Williams, Ruhlmart, okay, these design another one, and that is how the evolution happened in the neural network part. What is the need of it? Complex data. So traditional algorithms fail when analyzing huge non-linear data sets. See, so when I said linear and non-linear, so it is mentioned here. When you have a non-linear data, definitely you are going to use the neural network. Human-like recognition. Just like a human thinks, make able to reason, generate some reason. Okay, in the same way, we are designing some neural network which can do same sort of work. Getting my point? Yes or no? And finally, we have the adaptability. So neural network handle high dimensional data without explicit programming of each scenario. So when we say high dimensional data, what do you mean by high dimensional data? Anyone? How can you define high dimensional data?
I think it's data with many features.
How many?
I said data with many features.
Okay, how many features? Okay, how many features? Fine. Right. So understand here, we are not
Maybe 100, 1000.
correct, correct, correct. Okay. We are not talking about here the dimensions, that is x, y, z dimension. No, it's not like that. Dimension here means when you have a very high number of variables, high number of characteristic about the data. Okay, that is what high dimensional data is all about. So how the neural network works? So we have output layer, hidden layer, and input layer. So first of all, raw data got received, hidden layer, that is dense layer, pattern detection and feature transformation. That pattern detection and feature transformation are part of your we call it as feature extraction process, right? Where you are extracting the features, where you're extracting the characteristic from the data. Okay. Generally, we do this type of things in your object detection part or the CNN part. Finally, we have the output layer. Output layer we already discussed that how the output is going to be generated either on the basis of the type of dependent variable you are using, whether you are using a binary dependent or multi-class classification, you can say dependent variable. In that case, your output layer gets different type of neurons. Finally, we have input. So these are simply the details, some sort of example about the input layer. So here each node represent one input feature from the raw data. Then image example we have taken. So let's suppose for example there is an 28 by 28 pixel image, needs 784 input node, one for each pixel. So how we are going to calculate the 784? It is going to be calculated through the multiplication of 28 by 28. Then we put it with some weight and some bias values, and finally we got this 784 input. Okay. Now input values are typically scaled between 0 and 1 for optimal processing. Right. As I said, that optimal one, the binary one will be a 0 and 1. Right. Then another one is this hidden layer. Again, higher level features, mid level feature, and low level feature. So edges, color, basic shapes, that comes under the low level feature. Mid level feature, combination of basic pattern. Basic pattern means, like for example, you are doing some you can say you are finding some trends, you are finding some pattern from your data. Okay, from patterns like or trends like, let's suppose for example I'm talking about some weather data. Okay, some weather forecasting you are going to predict some economy. Okay, that there you can understand this basic patterns and combination. Then we have higher level features, that is complex patterns and abstraction part. Okay, so this is quite good scenario, or quite highly, you can say, complex one, in which you need to calculate weight, you need to define a lot of number of dense layers, you need to define, you can say, flatten layer as well, pooling layers as well, right? You need to define convolutional part as well. You need to define your output layer. You need to define sigmoid functions. You need to define optimizers. Okay, so that comes into this higher level features. And then we have this output layer prediction. So binary is this. Then we have digit recognition. This is an example, very famous example. If you search with MNIST, okay, you will get a lot of idea about this, that how the digit recognition happens. And finally, we have the ImageNet. ImageNet is one of the most accurate neural network or the framework available right now, okay, that you can use to work on object detection part, right? And this is your type of activation functions. So sigmoid is there, 10H is there, and ReLU is there. So as I said, sigmoid, it compresses output between 0 and 1, good for binary classification, output between -1 and 1. Zero centered, help with training stability. And return input if positive, else 0. Okay, means if there is a, you can say, if there is any output which is coming as negative, so it will result it as 0. Otherwise, it will generate a positive result always. Okay, so it is mentioned here the most popular for efficiency and reduced vanishing gradient. So vanishing gradient is the you can say vanishing gradient is a not a disadvantage, but kind of you can say kind of a lag when you apply the gradient descent part on the neural network. Okay, gradient descent is basically finding the optimal, or we call it as a minima. Okay, that is we are finding the best learning rate, right? So there we use this vanishing gradient part. And then we have this real life example. So as I said, that there is a very famous example for MNIST. Okay, you can do this MNIST and all that things. And finally, we have this some examples that where you can use the ANNs. So robotic, we all know there are a lot of example right now. We have autonomous vehicle, autonomous industrial robots as well, right? Now we have commercial robots as well. Okay, you can use it in your home as well. Language, you can do interpretation, you can translate the language using the ANNs. Then on the healthcare sector, detection of the diseases, okay, finding early detection, early diagnosis of a particular disease or a complex one, right? That is very you can say simple nowadays through the introduction or through the use of the neural networks and autonomous vehicle, as I already said. So these are some examples that you can understand where you can use the ANN part. Right now, if anyone have any question or doubt from this, you can go ahead. Okay. Guys, anyone? Any question or doubt?
So
If
Sachin,
not,
I do have one question.
uh,
So I think are we at the end of this today's session, or so we can or we do have few more pages to turn?
uh, So for today's session, sir, I am only left with the implementation part. So I'm just waiting if anyone don't have any question or doubt, I'm going for the implementation now.
Okay, okay. Then I do have a one question. Then I will hold my question for the end of the sessions. Okay.
Sure. Okay, so fine, guys. I hope I don't have any question, right? So let's move on with the implementation. Just give me a moment. I'll stop sharing it. And okay, I need to. Okay, let me do one thing. Just remove my pen tab. Fine. So right. Horizon, share the screen, title, done. So here we are going to do some basic implementation, right? I'm not taking a very complex data right now. I'm simply taking a ANN, right? Let's say it's a churn model basically we are trying to design. So I'll start with importing the basic libraries. Okay, I hope what libraries we are using here. So we are using pandas to handle the files. Then we are using the NumPy to work on your numerical part of the data. Then I also want uh, okay, let's forget about the matplotlib because we are not dealing with the EDA right now. So so let's just go with this, right? Only two, fine. Now, once we have imported it, so let's suppose df is equals to pd dot read csv, and I have a file available that is called bank. Just a second, what is the name of the file? Bank churn modeling. Okay, bank churn modeling. Fine. Bank underscore churn underscore MODELLING modeling dot CSV. Right. Execute this. Done. So let's check what I have in this data. So df dot head, and once I execute it, so I'm getting that these are the you can say these are the variables I have in my data. So starting from a row number, customer ID, surname, and so on, right? And finally, we have exited. Exited is in the binary nature, that is 0 and 1. So what is the primary aspect of this data? Let's understand a little bit about that. Data here, we are dealing with a banking sector data, and we need to do the churn analysis. Okay, churn analysis means that we are going to find that in near, you can say, or the next year or the next few, in the near future, how many customers are going to leave the bank or how many customers are going to stay with the bank. Correct? That is what we are basically doing in this, right? Okay, so first of all, if you look here, I have three variables. As I said, if you remember, I said that data should be clean. So the very first thing, that very first process that you are going to apply is the clean your data, right? If you look at the data right now, I have row number, customer ID, and surname, correct? Which I am not finding it's a relevant one. The reason behind it, that any bank is not going to particularly assign special service to any customer, correct? Any bank is not going to assign any special service to any or any of the customer, or they are not dealing for a specific group of the customers as well, correct? It might be possible that some exceptions are there, but in general way, there is no. So what I'm going to do from the df is equals to, I'm dropping these irrelevant one. You can find it using the correlation as well. So df is equals to df dot drop, and what I'm going to do, I'm dropping these. Okay, so in the drop function, I'm going to apply all of mention all of this. So first is my row number, done. Second column I'm going to use here, that is customer ID, customer. Sorry, make it as column customer ID. Then the third one I'm going to use as surname. Okay. Put the square bracket, close it up. Now, but see here, understand, if you have a little bit idea about how to work with a Python, so we are dealing with columns here, right? And if I need to drop the columns, if I need to refer to the column, I need to mention one parameter, and that parameter is called as axis, right? So can anyone tell me what how I can refer to the columns in Python? If anyone having any idea, what should I write there? Axis is equal to,
One for the
can you come again a little bit louder?
averages equals to 1. That is
X
for
is
the
equal
columns.
to, correct, x is equals to 1, exactly. Because we are dealing with the columns here. Okay, so x is equals to 1, I just execute this, done. So I have dropped the column now. Now if you check that after removing the this one, so this is my another data. Okay, not, I'm not saying that it's a quite well cleaned, but now it's a good one. Okay, so first of all, df dot is null dot sum. What I'm doing here, I am finding, is there any null value in my data? Null value means, is there any blank cell or a blank column in my data? Okay, not column exactly, but blank cell in my data. The reason behind it, that if there is any blank data and you apply any algorithm on it, it might be possible that your algorithm or your model get a low accuracy, right? When you pass a new data to your model, it might get into overfitting situation. Overfitting situation mean getting high accuracy on the trained data, but getting a low accuracy on the new data. That is what overfitting is. Okay, so to restrict that part, first of all, we need to work on the null values. If you have null values, we can impute them. There are different methods we can do, like MNR is there, MNAR is there, MAR is there, right? So there are types of categories we are going to deal with the null value. So I will check just here. So I'm getting that there is no null value as of now. So it's pretty good for us to go with this right now. Now, another thing, if you look at this data, right? Now, can anyone tell me, is there any anomaly in this data, or it is good? We can use this for the implementation. Anyone? Okay, see. So anomaly here is that if you look at these two columns, that is geography and gender, it is currently in the text format, right? And to implement any of the algorithm, you need numerical values. You can't apply any algorithm on the you can say on on textual data, right? Unless you are not dealing with NLP part. Okay, we are not dealing NLP. We are applying ANN here. So what we need to do, first of all, I need to convert this textual data into a numerical format, right? So for this purpose, there are different methods. Either you can use the label encoder, you can use the one-hot encoder. There are auto encoders as well for the neural network as well, right? But I am applying the very simplest one here, which is called the map. Okay. So let's begin with this. So DF in the GEOGRAPHY, Chakra. Right. In the geography column, what I'm saying that make it make this column as 0 or 1, right? So what I'm saying here is, let's suppose, for example, in this geography column, if you look at the data, okay, I will pass this data. If you look at this data, so in this, I have 3 types of category, okay, that is France, Spain, and Germany. So what I need to do, I need to categorize them. I need to define some values to it. Okay. So what I'm saying is that here I'm using a map function, map, and I am mentioning here that let's suppose France, right? France I'm mentioning at 0. Then let's suppose SPAIN. Spain I'm mentioning as 1. And finally, we have Germany, right? Germany I'm mentioning as 2. Okay. Now, is this you can say if this structure or this, if this step is clear to everyone or not? What we are doing here, is this clear? Anyone have any question or doubt? Okay, fine. Okay, so we are not dealing here. Sorry. Parenthesis should be curly braces. Execute this, done. We have changed the geography. Now, if you look at the data set now, right? df dot head, and if I execute it, you can see now geography column is changed to numerical values. Okay. Same way, I'm going to define the. Let me just copy this, make it quick. So instead of geography, now I'm going to work with gender. So it will be gender map. Let's suppose I'm saying male, sorry, male to 0 and female to 1, right? And just remove it up. Execute is done. And if I check again, the df dot head is there. And you can see now your geography and gender comes into a numerical format now. I hope this is clear to everyone till this part. Yes or no? Anyone have any question, doubt about this method that we have applied? Okay. No. Now we are coming with the most important point of working with the neural network. And what is that? I need one library here, which is called TensorFlow. Okay. This is the primary library to work or to design any neural network, right? So I will write TensorFlow. Let's give it enter, and it will take some time. So be patient and don't do anything right now. So it is downloading everything from the pip, that is Python image packaging. Once it download everything, you will see a kind of return message. Okay, so let's just wait. It is downloading. It's done. Okay, let's check whether it is working or not, right? So I need some other component from this, because from this TensorFlow, right? Not given from TensorFlow dot. It's not given. Okay, it is downloading. It is not installed yet. Let exercise. Okay. Right. TensorFlow dot keras. Anything there? Okay, let's check utils method is import to historical, right? I execute this. Tensor board is there, keras is there, TensorFlow is there. Okay. Okay, title is there. Okay, it is working on it right now. It's taking time. Signal is not so fine.
Can you check the spelling of Keras?
Signal is busy right now. All right. Guys, see, this is the issue, right? If you are creating a neural network, if you are configuring a neural network, you have to wait, okay? Because there are a lot of libraries, there are a lot of methods that this TensorFlow or the Keras will need, right? Just a second. Maybe it's typo there. No, typo. Oh, sorry. Sorry. That's good. That's good. E R S Keras. Right. Now, enter, done. Now TensorFlow already imported. Let's simply go. TensorFlow philosophy first or okay. It's not. It's not touching it.
Sachin, what we can because it's already more than 2 hours, and guys, we can resume the this session because it is a not a single day session. We will have a consecutive continuation from the next couple of weeks as well. So like our DevOps session, we can start from our next week Friday session from here. Is it okay, Mr. Sachin?
Sir, can you come again?
So now it is already more than 2 hours, right? So
Yes. Yes.
yeah, how about if we resume our things the next Friday, because we do have like a consecutive things. So
Mhm,
and many
mhm.
of the times you will find that it is not going to end with the due time. Now I
Correct. Correct. Correct.
before we conclude our session, I
Mhm.
do have a certain things to discuss, and I supposed to ask a very important question to you.
Sure,
Uh,
sure.
so before I ask the question, guys, we also do have a DevOps free session and cybersecurity free session in after 12 hours. That is Saturday morning for US and Saturday evening for Indian time. If you are in the group, please check, and you will find the same link, but the timing will be little bit different. Our cybersecurity job ready courses started today. These are 2 months long, and Mr. Karthik is right now taking our first session of our cybersecurity DevSecOps job ready training, which is actually a paid training that is directly aligned with our consultancy. So that was started. But after 12 hours, that is Saturday US time and Saturday evening for Indian time, we'll have a two more session for DevOps. First 2 hours is for cybersecurity and DevSecOps, and the next 2 hours for Mr. Devashish DevOps session. Right now, any question for that, guys? Feel free to ask about the timing and the other stuff. This batch is very silent and I don't know, maybe a little shy. uh, so, Sachin, I do have a very integral question of this course. So, like, just think if a guy with a not a technical expertise or non-tech people,
Hmm.
is it possible for them to find a job as a data scientist or AI engineers with maybe 2 or 3 years, 2 or 3 months classes? Is it possible for them to hop in on this, you know, the trendy job market about this AI developer or data scientist with AI expertise?
Hmm. 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 Okay. See, if my answer is quite honest and it's not biased, right? Definitely, you can crack any interview. Lot of you can say a lot of people have transitioned their career into the machine learning or the data science, okay, or the data engineering or even the AI role as well. The thing is, you need to be very practical. You need to be very you can say curious about the things and must be very good in your concepts, right? I'm not saying that at the very first moment, because see, obviously you go as a fresher, right? So not every company is just put everything on you. Definitely, okay. To crack as a fresher is easy. Only thing is that you need to be the best in your domain. Okay, you need to be best in your programming skills. You need to be best in your uh, conceptual things, right? No company is going to ask about designing a neural network in the interview. No company is going to ask to do some statistical modeling in the interview. Okay, no company will ask. The company only asks that how much concepts you are clear. Okay, so if you have that understanding, if you have that caliber to work on, if you have that uh, you can say grasping power, working power, okay, and the most important thing, if you have consistency to give. Simple. If you are not consistent in your learning, no one can do anything. If I can, even if I provide you the lecture of NGU as well, right? You will not able to crack any interview unless you are not consistent, unless you are not practicing your thing, and unless you are not learning the things by your own. That is the key.
Okay. And what is your thought as you know as you design that training course? I'm talking
Mhm.
about job ready training course for 2 months long or one and a half months long. I am not exactly aware of the timing
Uh-huh.
or the duration, but so is sufficient enough to people who have a little bit idea about Python or maybe no idea about Python? Is it a good enough time our course is good enough to put them or make them ready for a job like in this
So
particular domain?
the thing is, we are going to start from the basic, okay, from
Hmm.
the scratch.
Hmm.
It's not about that if someone having any understanding of Python, so we directly jump onto a certain topic. No. If we have pressure, that is our non-tech background. If you have some tech background, participate
Okay.
both, right? We
Hmm.
are dealing on a same scale. We are going to start. I'm going to start from the same scratch point. That is
Okay.
from installation of the software, what kind of IDE that you are going to use, what are the pros and cons of the IDs that you are going to use, Okay, how the installation work, how the library work, how the basic syntax of the Python work, and then we will move to a module. We will increase one by one complexity. We will go for the functions, and then we do discuss about the programming things, object-oriented programming thing, and so on. So that is how the curriculum I have designed.
Okay. Now the fun fact is we do have previously we have also many conducted many AI and data science classes, and we do have a quite good number of success stories whose people where people not at all coming from a uh, IT background, totally non-IT
Mhm.
background, and eventually they landed a job on our with our different training like DevSecOps. They landed with in different cybersecurity positions. Same goes for our AI and other training, but that was the common question, and I think, and that is a very valid question, that whenever some people you know try to plan for their future endeavor, they should aware like what what is the course about and what is the end goal, and the same time do you suggest some prerequisites for this particular course, that even before the course, if they can get little bit ready for certain things or certain points on certain topics on based on AI or data science? Would you like
Okay,
to suggest any?
so prerequisite, if uh, as of prerequisite, I'm not mentioning any of as of now. But
Hmm.
yes, if it's possible for someone who wants to join this course, uh, at least get some basic idea, okay, about the things that you are going to explore. I'm not talking about
Yes.
that go into the deep dive of it, right? Just understood the entire concept by your own. No, it's not about. I'm saying that if you understand that where I can use it, let's suppose, for example, if I am going to learn, let's say I'm saying that I'm going to learn how to drive a car. Okay, so first of all, I must need to understand if I know this, what is the benefit of it, right? So that is the only prerequisite. Yes, other things that if you are able to understand Python, or you can able to start by your own with the basic of a Python, that is a good one. Otherwise, we are going to cover everything.
Okay, okay, totally makes sense. Okay, thank you. And I think we are going to discuss furthermore about the US job market, about the AI trend in the next week, and some of the definite uh, technical terms coming from Sachin. And next week, hopefully, we'll have more interesting and same kind of things we can learn something new like today. Thank you,
Definitely,
Sachin.
definitely. Thank you, sir.
Thanks a
Thank
lot.
you. Thank you,
And
everyone. Thank you.
thank you everyone, and please share your thoughts in the group. And if you have any question doubt, feel free to ask, because it should be an interactive session, and we try to bring the help on the community, because we do have two different training. One is paid, one is free. The free training's only agenda is to bring create awareness. It is
Mm.
not about the promotion, and I think you in last 2 years you mostly heard about everything about the technical stuff, not about promoting something. So next couple of weeks you'll learn mostly uh, the in and like, if I cannot say this like in depth, but yes, you will have a high depth, high level ideas about that domain. Am I correct, Mr. Sachin?
Yes, yes, definitely,
Yeah.
definitely.
Thank you, sir. Thank you, everyone. Thank you, Sachin, sir. Thank you, Mr. Devashish. Have a
Thank you, sir. Thank you.
uh,
Thanks, everyone. Thanks.
Thanks a lot, Sachin, for a fantastic session.
Thank you, sir.
Really appreciate.
Thank you. Thank you.
Thank you.
Thank you, guys. Thanks for joining the session and giving us this
Thank
time.
you, Mr.
I
Sachin.
hope I think that most of you have joined. It might be for more some of you it's late night,
yes,
midnight,
little
or
late.
something. Yeah. So so
That's the reason I
thank you
asked.
everyone for giving us
We,
this time.
yeah, yeah.
So that is all from my side for today. We
Yeah.
will see you in the next weekend. Till then, have a good day, guys. Goodbye. Thank you. Yeah.